Good morning. What we have on display here are the ROHM isolated gate drivers. These drivers come in two isolation voltage ratings, 2,500 volts RMS, 3,750 volts RMS. The drivers feature coreless transformer isolation. We have a fixture that I would use now to demonstrate one of the best features of the driver, which is the high common mode rejection. The setup includes one of our BM6001 drivers, a battery to operate the primary, another battery to operate the secondary. Here's a schematic diagram of the fixture. So what we have on the primary side is a 32 kilohertz oscillator which runs from the battery. The 32 kilohertz goes to the input of the driver. The output of the driver feeds the yellow trace of the oscilloscope. So the yellow trace is 5 volts per division, so you can see the normal output is swinging from 0 to about 12 volts. Now the green trace represents a voltage coming from the noise-kin transient generator. The noise-kin is going to introduce a voltage on the primary side of the driver that's 150,000 volts per microsecond. The pulse occurs when I press the red button. Now the pulse is totally asynchronous with the 32 kilohertz oscillator, so what you see on the oscilloscope shows when the pulse happened to occur. The last time it was pressed, it happened to occur when the signal from the 32 kilohertz was low. If I press it again, you can see it shifted slightly. Again, right on the edge. Again, low. And there's one caught when the pulse was high. Now, I'll spread out the capture. This is now at 5 nanoseconds per division. The probe sensitivity for the green probe is 100 volts per division. So we have 1, 2, 3, slightly over 300 volts with a rise time on the order of 2 nanoseconds. This translates out to 150,000 volts per microsecond. If there were any corruption of the square wave, you would have noticed a change in the duty cycle. Therefore, the part is tolerated 150,000 volt per microsecond, common mode. We specify it at 100,000, which it does quite comfortably. This is of great benefit to those who are driving both high and low side devices, because the high side most often slews to whatever bus you're dealing with and back down in a very small amount of time. So immunity of the driver to common mode is of primary importance. Thank you.